AI application in the medical field MRI-based cancer detection using deep neural networks. Foundations of Artificial Intelligence Group 4 Salia Vanessa, which is me, Fakir Rahimsyah, Alif Kurniaullah, Kiki Maulana, Khalid Hanif Meutuwa. Table of Contents Objectives Introduction to AI in Medical Imaging. 2. Methodology Deep Neural Networks, the engine of transformations. 3. Result Analysis Application of DNNs in MRI-based cancer detections. 4. Conclusions Advantages of DNNs in MRI-based cancer detections. 1. Introduction to AI in medical imaging. Application of DNN in MRI-based cancer detections. Introductions. The healthcare industry is on the cusp of profound transformation, driven by the accelerating rise of artificial intelligence. AI, in essence, refers to the development of computer systems capable of performing tasks that typically require human intelligence. These tasks encompass a wide range of cognitive functions, including learning, problem-solving, decision-making, perceptions, and even understanding of natural language. Within healthcare, AI is rapidly moving beyond theoretical discussion to practical application, promising to revolutionize everything from disease diagnosis and drug recovery to personalized treatment plans and operational efficiency. This paradigm shift holds immense potential to enhance patient outcomes, reduce costs, and address some of the most pressing challenges facing modern medicine. Background. First, importance of early cancer detections. Early and accurate cancer detection is crucial for successful treatment and improved patients' outcomes. Role of MRI in cancer diagnosis. The advantages of magnetic resonance imaging (MRI) as a non-invasive imaging modality for visualizing soft tissue and detecting subtle abnormalities. 3. Limitation of traditional MRI interpretations. The challenges of human-based interpretation, such as interreader variability, fatigue, or the sheer volume of images. 2. Methodology. Deep Neural Network (DNNs), the engine of transformations. Deep Neural Networks, or DNNs, the engines of transformation. DNN as a subset of machine learning, utilizing multi-layer artificial neural network to learn intricate patterns from data. Key DNN architectures for medical imaging. Convolutional neural networks (CNNs), well suited for image analysis due to their ability to automatically learn hierarchical features. For example, edges, textures, shapes from raw image data through convolutional layers and pooling operations. Image classification and segmentations. How DNN learn from MRI data. Data input MRI scans, T1 weighted, T2 weighted, diffusion weighted, etc. as input. Feature extractions. DNN automatically extract relevant features unlike traditional methods requiring manual feature engineering. Pattern recognitions. Learning complex patterns associated with cancerous lesions versus healthy tissue. Classifications or segmentation outputting a probability of malignancy, classifying types or segmenting tumor. This is the example of deep neural network. So we already give you the example of the input layer, and then we have the output layer. What happened inside is a lot of filtering information and classification that happen within deep neural networks. So it's very hard to check whether what happened inside. It's like a black box. This is the example of MRI in tumor detecting or cancer detections. First, we have the data, we have the image, and then we have the input, which is shape, intensity distributions, and textures. And then we go through DNN, GAN expression profile, and two radiometric trait. And here, GAN expression in tumor tissues. We have a heat map, and then after that, we will have the trait, which is radiomic traits in feature mapping, which will show what caused it, like how deep the texture, intensity of distribution, and the shape of it. We can check it on the heat map. It's to make it easier to see for the computer because computers see in bits. Second, we have neural network train, AUC, neural network train score. Logistic regression, support vector machine, random forest, gradient boosted news. Gradient boosted trees. AUC, average precisions, accuracy. In a new study, researchers tested the ability of their deep learning network model to predict radiogenomic features against that of other classifiers within the same training datasets, and found that its overall performance was better. Okay, so what we see in here is the graphic showing the neural network task scores, and we have texture, shape, statistic, log, and wavelength, and then the difference of the wavelength itself. So we have the shape of it to map out within the graphics, and we can see how the distribution goes. MRI-based artificial intelligence (AI) research on patients with brain gliomas cancer. So this is what actual data would look like if we are using MRI with AI system. So first we have the real MRI data, and then we can actually progress to check the texture, the size, and the intensity based on the data that we have. And this is like the map for that. And this is a real data from 2025 data. Result analysis. Application of DNN in MRI-based cancer detections. Deep results. Deep neural networks (DNNs) in MRI-based cancer diagnosis. Application. Cancer detection. How do deep neural network DNNs help? A DNN analyzes MRI scans to automatically identify and flag suspicious lesions. Typical success rate: 90% up to 89% accuracy from the data. Analysis in identifying tumors correctly. Second, tumor segmentations. How deep neural network helps? A DNN automatically paints the exact 3D outline of the tumor pixel by pixel. In tumor segmentation, typical success rate is 85% up to 95% overlap. The analysis, compared to a human expert's drawing, dice score. Cancer grading. The DNN learns subtle patterns to classify a tumor's aggressiveness. Example, malignant and benign. 85% up to 95% accuracy in correctly classifying the tumor type or grade. Prognosis predictions. The DNN analyzes the tumor appearance to predict future outcomes. like respond to therapy, 75% up to 85% accuracy in predicting if a patient will respond to the treatment, faster MRI scans. A DNA reconstructs a clear, high-quality image from very fast, noisy scan, up to 75% reduction in scan time, with comparable image quality to a slow scan. 4. Advantages of DNNs in MRI-based cancer detections. Abnormality, segmentation, interpretations, ambiguous data. Accuracy and sensitivity in abnormality, segmentation, efficiency and speed, interpretation, reduce interreader variability, doctor or radiologist, ambiguity, potential for personalized medicine and handle large datasets. Future directions and research, multimodal integrations, and it creates a foundation models in medical AI, and then it creates federated learning. It also creates explainable AI or XAI for clinical trust, and then real-world clinical validations and prospective trials. In the future, medical communities and patients will benefit from addressing challenges related to diagnosing critical diseases. Salia Vanessa. Thank you. Do you have any question? And this is the resources or reference that I use for the presentations. Hope you find this insightful. Thank you.